FASTQ format is a text-based format for storing both a biological sequence and its corresponding quality scores. Both the sequence letter and quality score are encoded with a single ASCII character for brevity. It was originally developed at the Wellcome Trust Sanger Institute to bundle the FASTA sequence and its quality data, but has recently become the de facto standard for storing the output of high-throughput sequencing instruments such as the Illumina Genome Analyzer. Format A FASTQ file normally uses 4 lines per sequence. Line 1 begins with a character and is followed by a sequence identifier and an optional description. Line 2 is the raw sequence letters. Line 3 begins with a plus character and is optionally followed by the same sequence identifier again. Line 4 encodes the quality values for the sequence in line 2, and must contain the same number of symbols as letters in the sequence. An FASTQ file containing a single sequence might look like this. At SEQID, plus 0.1 plus 55 CCFCCCCCCC65. The character exclamation mark represents the lowest quality while tilde is the highest. Here are the quality value characters in left to right increasing order of quality. $in plus. /012345678 equals. At /apkgenopstov wxyz, /apkgenopstov wxyz. The original Sanger FASTQ files also allowed the sequence and quality strings to be wrapped, but this is generally discouraged as it can make parsing complicated due to the unfortunate choice of @ and plus as markers. Illumina sequence identifiers, sequences from the Illumina software use a systematic identifier. At HWUSIAS 100R, 673 941 1973 number 0/1. Versions of the Illumina pipeline since 1.4 appear to use NNNNNN instead of number 0 for the multiplex ID, where NNNNNN is the sequence of the multiplex tag. With Cassava 1.8 the format of the IT line has changed. At DAS 139 136 FC706 VJ, 22104 15343 197393 1, Y1880 CACG. NCBI Sequence Read Archive, FASTQ files from the NCBI EBI Sequence Read Archive often include a description, for example. At SRR 1666.10711112 SLXAAS1 S751 345 length equals 36, GGGTGATGGCCGCTGATGGCAC, plus SRR 1666.10711112 SLXAAS1 S751 345 length equals 36, I9IG9IC. In this example there is an NCBI assigned identifier, and the description holds the original identifier from Solexa Illumina plus the read length. Also note that the NCBI have converted this FASTQ data from the original Solexa Illumina encoding to the Sanger standard. Variations, quality. A quality value Q is an integer mapping of P. 2 different equations have been in use. The first is the standard Sanger variant to assess reliability of a base call, otherwise known as FAT quality score. The Solexa pipeline earlier used a different mapping, encoding the odds P/1P, instead of the probability P. Although both mappings are asymptotically identical at higher quality values, they differ at lower quality levels. At times there has been disagreement about which mapping Illumina actually uses. The user guide for version 1.4 of the Illumina pipeline states that the scores are defined as Q equals 10 log 10, P/1P, SIC, where P is the probability of a base call corresponding to the base in question. In retrospect, this entry in the manual appears to have been an error. The user guide for version 1.5 of the Illumina pipeline lists this description instead, Important changes in pipeline v1.3, SIC. The quality scoring scheme has changed to the FAD, that is, Sanger scoring scheme, encoded as an ASCII character by adding 64 to the FAD value. A FAD score of a base is, where E is the estimated probability of a base being wrong. Encoding, Sanger format can encode a FAD quality score from 0 to 93 using ASCII 33 to 126. Also used in SAM format. Coming to the end of February 2011, Illumina's newest version of their pipeline Cassava will directly produce FASTQ in Sanger format, according to the announcement on sequencers.com forum. Celexa Illumina 1.0 format can encode a Celexa Illumina quality score from -5 to 62 using ASCII 59 to 126, starting with Illumina 1.3 and before Illumina 1.8. The format encoded a FAD quality score from 0 to 62 using ASCII 64 to 126. Starting in Illumina 1.5 and before Illumina 1.8, the FAD scores 0 to 2 have a slightly different meaning. The values 0 and 1 are no longer used and the value 2, encoded by ASCII 66b, is used also at the end of reads as a read segment quality control indicator. The Illumina manual states the following: if a read ends with a segment of mostly low quality, then all of the quality values in the segment are replaced with a value of 2. This Q2 indicator does not predict a specific error rate, but rather indicates that a specific final portion of the read should not be used in further analyses. Also, the quality score encoded as B letter may occur internally within reads at least as late as pipeline version 1.6, as shown in the following example. At HWIEAS 2090006FC706VJ, 558-58-94-21141 plus HWIEAS 2090006FC706VJ 558-58-94-21141 CACG/1, EFCFFFFCFEEFFFCFFFFFDDF feed bar, YBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBBbbbbbbbb Also, in Illumina runs using Phi-X controls, the character B was observed to represent an unknown quality score. The error rate of B reads was roughly 3 FAD scores lower than the mean observed score of a given run. Starting in Illumina 1.8, the quality scores have basically returned to the use of the Sanger format. For raw reads, the range of scores will depend on the technology and the base caller used, but will typically be up to 41 for recent Illumina chemistry. Since the maximum observed quality score was previously only 40, various scripts and tools break when they encounter data with quality values larger than 40. For processed reads, scores may be even higher. For example, quality values of 45 are observed in reads from Illumina's long-read sequencing service. Dollar in plus /012345678 equals at @apkfkjnopstov WXYZ \apkfkjnopstov WXYZ 33 59 64 73 104 126, 0, 26. 31, 40, 5, 0, 9, 40, 0, 9, 40, 3, 9, 40, 0.2, 26. 31, 41. S. Sanger plus 33, raw reads typically, X. Selector plus 64, raw reads typically, I. Illumina 1.3 plus FAD plus 64, raw reads typically, J. Illumina 1.5 plus FAD plus 64, raw reads typically, with 0 equals unused, 1 equals unused, 2 equals read segment quality control indicator. L. Illumina 1.8 plus FAD plus 33, raw reads typically. Color space. For solid data, the sequence is in color space, except the first position. The quality values are those of the Sanger format. Alignment tools differ in their preferred version of the quality values, some include a quality score for the leading nucleotide, others do not. The sequence read archive includes this quality score. Compression. Quality values account for about half of the required disk space in the FASTQ format, and therefore the compression of the quality values can significantly reduce storage requirements and speed up analysis and transmission of sequencing data. Both lossless and lossy compression are recently being considered in the literature. For example, the algorithm QualComp performs lossy compression with a rate specified by the user. Based on rate distortion theory results, it allocates the number of bits so as to minimize the MSE between the original and the reconstructed quality values. Other algorithms for compression of quality values include ScaleSay and FASTQZ. Both are lossless compression algorithms that provide an optional controlled lossy transformation approach. For example, ScaleSay reduces the alphabet size based on the observation that a Euro or an ABO ring Euro quality values are similar in general. File extension. There is no standard file extension for a FASTQ file, but FQ and FASTQ are commonly used. Format converters. BioPython version 1.51 onwards, Emboss version 6.1.0 patch 1 onwards, BioPerl version 1.6.1 onwards, BioRuby version 1.4.0 onwards, BioJava version 1.7.1 onwards. MAQ can convert from Selector to Sanger. FASTX Toolkit. The included FASTQ quality converter program can convert Illumina to Sanger, command line conversions, FASTQ to FASTA format. ZCAT input file FASTQ GZ AUK NR%41PRINTF%S\n, SUBSTR, $0, 2, NR%42 print output file FAR. Illumina FASTQ 1.8 to 1.3. ZE4 to 4Y012345678 equals. Add appfeed my file FASTQ add to save the result to the same input file. Illumina FASTQ 1.3 to 1.8. ZE4 to 4Y. $and \+. \my file FASTQ add to save the result to the same input file. See also, FASTA format, FAD quality score, list of file formats for molecular biology, references. External links, MAQ webpage discussing FASTQ variants, FASTX Toolkit collection of command line tools for short reads FASTA FASTQ files pre-processing, FASTQC quality control tool for high throughput sequence data, Princic can be used for QC and to filter, reformat, or trim sequence data.